In today's exciting installment of pre-calculus, we're going to talk about trigonometric functions on the unit circle. The unit circle is defined to be a circle of radius 1. 1 what? It doesn't matter. This is just, we're sort of thinking of it. 1, 1. So the radius is length 1. And we define on it triangles whose hypotenuse is always 1. So if we take a line to the outside, that's always going to be the radius. If we use that as the hypotenuse of our triangle and drop a line straight down to the positive x-axis, then we get a right triangle. Now remembering what the definitions of sine, cosine, and tangent are, the sine of this angle theta will be the length of this opposite side to the length of the hypotenuse. Well, the hypotenuse is just 1. So the length of this opposite side is, well, let's think about it. If the point up here is xy, and that's where our line hits the edge of the circle, then the y value is the length of this side, because that's how far up you are from your x-axis. So this length is y, this length is x. If sine of an angle is the ratio of the opposite side to the hypotenuse, then sine of that angle is just going to be y over 1, which is just y. Cosine, since it's the adjacent side, well, the side going only over to this point, to where this line drops down, that's x. So cosine of theta will be x. The adjacent side to the hypotenuse is just 1, so cosine is just the length of this adjacent side. And tangent of theta is the ratio of the opposite side to the adjacent side, so that will be y divided by x. This may take some getting used to, but that is basically where we get everything from here on. A couple of little details that get a little harder to picture. We can also form right triangles for angles greater than 90 degrees. So if we come over here, we still want to be able to form a right triangle. So instead of dropping down to the positive y-axis, or positive x-axis, we drop down to the negative x-axis. And then we can still talk about sine and cosine in terms of x and y. We can go down here as well, and then our right triangle will just be here, or down here if we like, and draw it. So you're always drawing the right triangle to the nearest x-axis. Well, that means we can start talking about sines and cosines in these other quadrants where our x and y values are negative. So sine can be redefined, so it's no longer just for an actual triangle the ratio of the sides, but it's now defined to be the y value on the unit circle, and cosine is the x value on the unit circle. Obviously, cosecant, secant, and cotangent are defined on top of those. Since there are places where your x or y value may be 0, and you can't divide by 0, there are some places on the unit circle where cosecant and secant are undefined, and where tangent and cotangent are undefined as well. And you'll see that as we go. So the next thing we're going to do is fill out a unit circle based on this, and based on the special right triangles we reviewed, the 30, 60, 90, and the 45, 45, 90. Okay, the first thing we're going to do on our unit circle is fill in the angles. If you were in class, you should have a unit circle already filled out, or at least a unit circle. If you were not, you're going to need to get a blank unit circle and fill it in with us. So here are the angles that we will be expected to know on the unit circle. For those that are not among this list, we'll have other ways of finding them, but these are the ones that we expect to know. So this first angle is 30 degrees from the x-axis. The next one is 45 degrees away. The next one is 60 degrees. And the next one is 90. And it's going to keep going like that, 30, 15, 30. Let's see, 30, 15, 15, 30. So the next one will be 120 degrees, then 135, then 150, then 180. Then 210, 225, 240, 270, 300, 315, 330, and then this you can think of as either 0 degrees or 360 degrees, depending. Now, you may notice, I hope you notice, that these are the same as the angles we use in our special right triangles. That's on purpose. So if this is a 30, 60, 90 triangle, and it must be, using this green line as my opposite side, here's my theta, this is the angle we're going to measure from. This is my opposite side. The x-axis until I hit that green line is my adjacent side. And then this is the hypotenuse. Remembering that this is a unit circle, the hypotenuse will always be 1. So, for when you're talking about the unit circle, sine of your angle is going to be your y value, cosine will be your x value. So let's start filling some things in. First of all, not even thinking about trigonometric values, but you know what this point here is. This is length 1, or the radius of this circle is 1. This is just along the x-axis, so this point here is x equals 1, y equals 0. And for that matter, this point up here, we also know what this is. The length is 1, it's going straight up, so your coordinates are 0, 1. Over here you've got -1, 0, and down here we've got 0, -1. I always fill these in first, because these I know straight just from the graph. I don't even have to think about trigonometry. Now for the rest of these, we're going to think about those trigonometric values that we found on the special right triangles. In a 30, 60, 90 triangle, the value of sine of theta, the value of sine of 30 degrees is 1/2. Well, sine is our y value, so we're going to go ahead and fill in 1/2 as the y value for 30 degrees. Cosine of 30 degrees is square root 3 over 2, so cosine is my x value. So, looking at this point here, the x value of this point on the edge of the unit circle is square root 3 over 2, comma 1/2. For a 45-degree angle, the sine and cosine are both the same, square root 2 over 2, and square root 2 over 2. Sorry, this is a little hard to read. This down here is a square root of 3 divided by 2. Alright, at a 60-degree angle, sine is the square root of 3 over 2, and cosine is 1/2. So, x is 1/2, y is square root 3 over 2. And you can see that that's the same as the values at 30 degrees, only swapped. Now, as we get into the other quadrants, this is why I made such a big deal of reference angles, because the reference angles will have, angles with the same reference angle will have either the same sine and cosine or the opposite sine or opposite cosine. That is, they'll be the same magnitude, but they may be positive or negative. So in quadrant 1 here, everything is positive. X is positive, y is positive. In quadrant 2, x is negative, but y is positive. Oops, I don't know why I did that. That's kind of weird. Negative and y is positive. In quadrant 3, they're both negative. And in quadrant 4, x is positive and y is negative. So we're going to go around. The values will be the same, except the sign may change. So up here, 120 degrees has a reference angle of 60 degrees. They're symmetrical to each other. So that means the x value will just be negative 1/2, and the y value will be positive square root 3 over 2. So you're just going to fill in the numbers, and then the positive or negative will be based on this. So I'd like you to try going around filling the rest of them in based on this symmetry. pause this and do it, and come back and check if you got it right. Here are all the values filled in on the degree unit circle. In quadrant 2, x is negative, y is positive, so we go negative 1/2 square root 3 over 2, negative square root 2 over 2, square root 2 over 2, negative square root 3 over 2, 1/2. So to get the numbers, you just go with the symmetric one, and to get the sign, you just go with what quadrant you're in. In quadrant 3, everything's negative, so negative square root 3 over 2, negative 1/2, negative square root 2 over 2, negative square root 2 over 2, negative 1/2, negative square root 3 over 2. And in quadrant 4, positive 1/2, negative square root 3 over 2, positive square root 2 over 2, negative square root 2 over 2, positive square root 3 over 2, negative 1/2. That's that. So how do we use this filled in unit circle? So we are going to use the unit circle to find first some values. So sine of negative 90 degrees. You go to your unit circle. Negative 90 degrees, remember, means we're going to go clockwise instead of counterclockwise. So starting from 0, counterclockwise comes down here. So this is negative 90 degrees. The sine value is the y coordinate at your endpoint. The y coordinate here is negative 1. So sine of negative 90 degrees is negative 1. That's how you find the value. Cotangent of 270 degrees. Well, here's 270 degrees. Now, cotangent takes a little more work. Cotangent is the same as cosine over sine. And if you need help proving that, well, work on it a little later, ask me in class. But it is. It's cosine over sine. Since cosine is my x value and sine is my y value, cotangent is going to be 0 over negative 1 or just 0. Cosine of negative 180 degrees, again, it's negative, so we go backwards. So negative 180 turns out to be the same as positive 180. Cosine is your x value, so that's negative 1. And then secant of 90 degrees. So for secant, we go this, or for 90 degrees, we go up here. Now, secant is the reciprocal of cosine, so it'll be 1 over x. But x is 0, and you cannot divide by 0. So it would be 1 over 0, which is undefined. So we say secant of 90 degrees is undefined, or you could say, sometimes I will say, dne, for does not exist. The value of secant per 90 degrees does not exist. You can also use it to find all 6 functions for a particular angle. So we're going to look at 210 degrees. 210 degrees. For sine and cosine, we'll just take my y and my x. Negative 1/2, negative square root 3 over 2. So negative 1/2 for sine, negative square root 3 over 2 for cosine. For cosecant, we'll just take the reciprocal of sine, so negative 2. For secant, we'll take the reciprocal of cosine, so negative 2 over square root 3, or in simplified form, negative 2 square root 3 over 3. Tangent is sine over cosine. So that's negative 1/2 over negative square root 3 over 2, which the negatives will cancel out, and the halves will cancel out, although, all right, so let me write this whole thing out. Negative 1/2 divided by negative square root 3 over 2. Dividing by fraction is the same as multiplying by the reciprocal, so I can change this into times 2 over negative square root 3 over 3. Cancel this out. The 2's now can cancel out. And we get negative, and the negatives can cancel out. We get 1 over the square root of 3. That's got the denominator on the bottom, which we don't like. So it's square root of 3 over 3. Cotangent is the reciprocal, so we would turn it over. So that's just positive square root 3. If both your sine and your cosine are negative, your tangent and cotangent will be positive, because the negatives will cancel out. Oops, sorry. So that's how you do that. Now, we spent a lot of time getting the unit circle ready, but not everything relies on the unit circle. The values of the trigonometric functions are still based on right triangles. So you may get a problem that doesn't have to do with the unit circle at all, except except that we are now going to have negative side lengths for triangles, which is weird and doesn't really make sense in the real world, but when we think about it in the coordinate plane, it does make sense. So find the 6 trigonometric functions for angle theta in standard position. That is, the initial side will lie along the x-axis if a point with coordinates negative 15, 20 lies on its terminal side. So first thing I do in a case like this is I draw the triangle, I try and plot the point. So I plot the point, that's negative 15, positive 20, which puts me in quadrant 2. I draw a line, I draw a line connecting the origin and the point I drew, and then drop a line straight down from the point I drew to the x-axis. It's always the x-axis. So now I've got a right triangle. My theta, the angle I'm working with, is always going to be the angle at the origin. So now I'm finding my functions for angle theta. I should find my side lengths. This side length here, well, this is the x value, so this side length is negative 15. Weird, but true. It's negative 15. This side length, the y value, is positive 20. And then to find the missing side, I would use quadratic theorem. Now the hypotenuse in these cases will always be positive, so you don't have to worry about the sign. So we do 225 plus 400, take the square root, and we will get 25. Go ahead and try it out on your own if you want. Hypotenuse should always be positive. All right, now we're going to do all the trig functions. That's easy. Sine theta, should have typed this out beforehand, sine theta will be 20 over 25, or 4/5. Cosine, negative 15 over 25, or negative 3/5. Tangent, 20 over negative 15, or 20 over negative 15, or negative 4/3. Go ahead and reduce these. So this sine is 4/5. Cosine is negative 3/5. Tangent is negative 4/3. So cosecant will be 5/4. Secant, negative 5/3. And cotangent, negative 3/4. So the deal with a problem like this is you plot the point, draw the triangle, figure out the side lengths, pay careful attention to positive or negative, and then just figure out your missing side, do all your ratios. Okay, last kind of problem. So this, again, doesn't exactly rely on the unit circle, but it will rely on your knowledge of the coordinate plane and then the definitions of the trig functions. So suppose theta is an angle in standard position whose terminal side lies in quadrant 4. So we've got our usual coordinate plane. Standard position means the initial side is along the x-axis, and if the terminal side is in quadrant 4, I'm just going to go ahead and draw this like this. I mean, it could be like this, or like this, but this will do. It doesn't really matter. Why does it matter that it's in quadrant 4? Well, I'll tell you why it matters. In quadrant 4, your x value is positive, your y value is negative. So that means when you go to draw your right triangle, oops, by drawing a line straight up to the x-axis, before you do anything else, so that you don't forget, you need to make a note that your y value here is going to be negative, because that's going to change your answers. Now, if secant theta is square root of 29 over 5, well, secant is the reciprocal of cosine, so it's hypotenuse over adjacent. This gives us the ratio. It doesn't give us the actual side length, but we can use these as the side lengths because we're looking for ratios, so that'll be fine. So the hypotenuse, then, we're going to call it square root of 29. And the adjacent side, remember we're talking about this angle here, the adjacent side here is length 5. So to find the missing side, you do your Pythagorean theorem. 29 minus 25 is 4, square root of 4 is 2. Since we're in quadrant 4, this value is negative 2. And now we're ready to find all other 5 of the ratios. We don't need to find secant because it's already given to us. So sine of theta will be negative 2 over the square root of 29. or, oops, hold on. I apparently made a mistake. All right, my apologies. Let's try that again. What sign? All right, sine is negative 2 over the square root of 29, or negative 2 square root of 29 over 29. Cosine is 5 over the square root of 29, or 5 square root of 29 over 29. Tangent is negative 2 over 5. Cosecant is square root of 29 over negative 2, or negative, square root of 29, negative square root of 29 over 2. When the negative can be in any one of three places. It can be on the top, it can be on the bottom, or it can be outside. All those three things mean the same thing, but you can't use more than one of them or they cancel out. So I've just moved it up here. And cotangent will be negative 5/2. So you draw your triangle, you check for positive or negative very carefully because that's what trips people up on these. Make sure you know what's positive or negative. Use your quadratic theorem, find your ratios, and that's it.